Hi, everybody. Welcome to lesson 8.2. We're continuing our unit on systems of equations. Today we're going to talk about solving systems algebraically using the substitution method. Your aim today is that you can use the substitution method to solve a system of equations. There are a variety of ways we can solve a system of equations. In the last lesson, we saw how to solve them graphically. Remember, we solved systems by graphing and finding the intersection point. In this lesson, we'll review and understand the basis for solving them by a method known as substitution. You have seen this technique in Common Core 8th grade mathematics, but here we explore it more deeply. Exercise 1. Consider the system given below. This one, it's not really below, it's over here. And its solution is x equals 4 and y equals 1. Part A says, show that 4, 1 is a solution to the system. When this says show, this is another way of saying plug it in. So 4 is my x and 1 is my y. So I'm going to plug these in to each equation and see if it's true. So I have 2x plus y equals 9. Let's substitute in. X is 4 and y is 1. And let's see if it gives me 9. 2 times 4 is 8. And 8 plus 1 is 9. So it works for the first equation, but let's test it for the second. Y equals x minus 3. Y is 1 and x is 4, and yes, the solution works. In both equations, when I plug it in, I get the same thing on both sides. So it works in both equations. Part B, substitute x minus 3 in for y in the first equation and show the point is still a solution. So here's where we start thinking about substitution. Take a look at the system here, and notice that y is equal to x minus 3. So I can replace this y up here with the equation x minus 3. This is the basic idea of substitution. You're replacing a single variable with an expression. So we're replacing y with x minus 3 because they are equivalent. So I have 2x plus y equals 9, but instead of y, I'm going to replace it now with x minus 3. Instead of y, because they're the same thing. This right here is saying that they're equivalent, so I'm substituting it in. Now I'm going to get an equation that I can solve, because I've eliminated a variable, basically. I've gotten rid of the y by replacing it with something with x. And now I combine like terms and solve. 2x plus x is 3x, bring down the negative 3, bring down the 9, add 3 to both sides, and 3x equals 12. Divide both sides by 3, and x equals 4. Is that true? Yeah, I wanted that 4, so I'm okay so far. It worked. Now we still have to find y. So I'm going to take this x equals 4, and I'm going to plug it in to the other equation. Oh, wait, hold on. That's not what this is asking for. That's what we're going to do in the second part. So the second part says solve the system by finishing the substitution and from B. So that's basically saying, hey, now take the 4 and plug it in. Oh my gosh, my pen. Sorry guys, this pen, I swear. Plug into the other equation. So I'm going to take one of my original equations. Let's take y equals x minus 3. And now, instead of x, what can I replace it with? 4. So y equals 4 minus 3 is 1. Is that what I wanted? Yes, I got the answer 4, 1. X equals 4 and y equals 1 using substitution. This is a substitution method where you take an expression and you replace a single variable with the expression. Okay? Let's take a look at exercise 2. Substitution is a very important technique and we want to be very good at it. It boils down to one of the most important properties of equality. Equals may always substitute for equals. What that means is that if two things are equivalent, you can substitute it for the other. Okay, so let's take a look at A. A says y equals 2x plus 5 and y equals negative 3x minus 10. Because y equals negative 3x minus 10, I can replace this expression with the y in the other problem. So I have y equals 2x plus 5, but I'm going to replace y with negative 3x minus 10 equals 2x plus 5. I'm making that substitution. That's the key learning objective here, is making that substitution. The rest is just solving, right? Subtract the 2x on both sides to get the x on the left. Negative 5x minus 10 equals 5. Add 10 to both sides. And negative 5x equals 15. And finally divide both sides by negative 5, and you get x equals negative 3. Now in order to solve a system, remember I need an x value and I need a y value. How do I find the y value? I'm going to plug into the equation. It honestly does not matter what you plug, which equation you plug into it. You can pick the first one or the second one, it doesn't matter. So I'm going to pick this first one, y equals 2x plus 5. But instead of x, what can I replace x with now? Negative 3. Right? Now I can solve for y. 2 times negative 3 is negative 6. And negative 6 plus 5 is negative 1. So I get an answer of negative 3 comma negative 1. This is how you write your solution as a coordinate. And I put a box around it. Don't just leave it as x equals negative 3 and x equals and y equals negative 1. Make sure you write a solution as a coordinate. Right? A solution to a system is a x comma y coordinate. Okay? Alright, let's try letter B. Same idea, solve this by substitution. Well, I have that y equals negative 5x plus 13. So here's my y in my other equation. I'm going to plug it in for the y in the other equation. So I have 4x minus 2y equals 16. But now, when I make my substitution, I'm going to replace the y with negative 5x plus 13 equals 16. And then I'm going to solve this. So I've replaced, it's not negative 2 times y anymore, now it's negative 2 times my expression that y is equivalent to. And now we solve. I have to distribute the negative 2, so I get plus 10x and then minus 26 equals 16. Combine like terms, 14x minus 26 equals 16. Add 26 to both sides. And I get 14x equals 42. Divide both sides by 14. And I get that x equals 3. So I have the first part of my solution of my coordinate, which is 3. Now I have to take that 3 and plug in. So I'm going to pick the second equation, y equals negative 5x plus 13. So I'm picking this equation right here, that bottom one. But now that I know x, I can just replace the x with that 3 and find my y. Negative 5 times negative 3 is negative 15, and negative 15 plus 13 is negative 2. So now I know my answer is x equals 3 and y equals negative 2, and I've written that now as a coordinate 3 comma negative 2. Okay, that is the basic fluency for substitution method. Okay? Alright, exercise 3. The algebra of systems allows us to solve all sorts of problems that almost seem like riddles. In exercise 3, it says, Max and his father Kirk are comparing their ages. They know that the sum of their ages is 52, and that Kirk is 7 years older than 4 times Max's age. So that's a lot of information. Let's see what it wants us to do with it. A, if Max's age is represented by M, and Kirk's age is represented by K, write a system of equations that describes the two relationships from the problem. So, I've got two pieces of information. Here's the first piece of information, that the sum of their ages is 52. So, if I know that Max is M, and I know that Kirk is going to be K, let's write an equation for this first part. What does sum mean? Sum means we add together. So how would I add Kirk and Max together? Well, M plus K would be the sum. And what is it? It's 52. So there's my first system. Oops. Right, that's my first equation in my system. The sum of their ages is 52. Now let's look at the second piece of information they give us. Kirk is 7 years older than 4 times Max's age. This takes us back to Unit 3 when we were translating linear equations. So remember, Kirk is K, so I have K. This word is an equal sign, so I have is. 7 years older is 7 plus, than 4 times Max's age, so 4 times M. Now I have my two equations, and now I can answer part B. Part B now says solve the system using substitution to find both of their ages. So when I see my substitution, I notice that since I have k defined by 7 plus 4m, I'm going to replace this k with 7 plus 4m. So I'm going to have m plus k equals 52, but instead of k, I'm going to write plus 7 plus 4m. I've replaced the k with this expression. Okay, that's my substitution. Now I can solve. 4m plus m is 5m, kind of like terms. Subtract 7 on both sides to solve. 5m is going to equal 45. Divide both sides by 5, and I get that m equals 9. So now I know that Max is 9. But I have to find out how old Kirk is. So I'm going to take this 9, and again, like before, I'm going to plug it in. So I'm going to say k, I'm going to use the first equation, the m plus k equals 52. But now that I know m, I can replace m with 9 and get 9 plus k equals 52. Subtract the 9 to solve, and I get k equals 43. So Kirk is 43. Okay? So substitution method helps us solve some riddles, some word problems. You could have used this by graphing, but it would have been a little harder because you don't have a y and an x. You have a k and an m, and sometimes students struggle with knowing how to translate a k and an m to an x and a y grid. Okay? Alright, exercise 4. Two plans offer different texting packages. The two plans are outlined below. Plan A says $5 per month charge along with a charge of 3 cents per text, and Plan B has no per month charge but a charge of 10 cents per text. Is there a certain number of texts where the two plans cost the same amount? Determine your answer by setting up a system that models the two plans. So let's set up our system. Let's make Plan A purple, and let's write an equation for Plan A. So Plan A, okay, $5 per month charge along with a charge of 3 cents per text. So this 5, that's my starting. So that's like my y-intercept. So it's like my y-intercept or my b value. And this is my rate, the 0.3. So I'm going to have an equation that looks like this. Y equals 0.03x plus 5. Right? 0.03 is my rate and 5 is my starting point. Plan B, let's make it red. No per month charge, that means that's 0. So we're going to have something plus 0 at the end, so we're not even going to have a y-intercept. So this basically has a 0 at y, and a charge of 10 cents per text. So this is going to look like this, y equals 0.10x. And you could put plus 0, but we're not going to. It's just understood that if there's no number there, then your y-intercept is 0. Now we get to the point where this question says, well, will the two plans ever cost the same amount? Like if you use a certain amount of minutes, will they be the same? When you see this word same, you think equal to. So this wants you to take and figure out when these two things are equal to each other. So in another way to word this is you're going to solve this system and see when x is the same. So because y equals 0.10x, I can replace it into the other y here. So instead of saying y equals 0.03x plus 5, I'm going to replace this y with 0.10x. And now I've got an equation with just x's, and I can solve. Subtract the 0.03x on both sides. 0.10x minus 0.3x gives you 0.7x. Oh, wait, nope. Sorry. 0.07x equals 5. When I solve this and divide both sides by 0.07, I get that x equals a decimal of 71.42. What this tells me is that at 71 0.42 minutes, they will be charged the same amount. But on a cell phone plan, do they charge you for half a minute? Do they charge you for a fraction of minutes? No, they charge you for whole minutes. So because this answer gives me a decimal, my answer to this question is going to be no. They will never charge the same amount. This is one of those Common Core questions where it wants you to understand context. And there's a real-world application here. You have to be really aware of how cell phone plans work. You're all old enough now to know about these kinds of things. How much does your cell phone cost? You all have cell phones, and how do your plans work? Even if your parents pay for it, you should have an understanding that they don't charge for half a text. They don't do that. So this decimal is a big red flag that says, hey, look, these plans won't ever line up. And that's an understanding of the real world and how it works. And Common Core is expecting you to have that base knowledge, right, to answer some of these questions. So there's more going on than just math here. There's an understanding of how the real world works that you guys need to get familiarized with, right? Okay, last problem. A man and a woman start 380 feet away from each other and walk in a straight line towards each other. If she is walking at a rate of 6 feet per second and he is walking at a rate of 2 feet per second, when will they meet? There's a setup in this problem that's kind of tricky, but really important. Right, this is a really key important part. 380 feet away from each other. So she is 380 feet from him and he's 380 feet from her. You have to create a starting point. So I'm going to say that she is the starting point and she is at 0 and he is at 380. Now, they're still 380 feet apart, but this gives me a way to write a couple equations that will help me answer this question. So I'm going to write an equation for her, and I'm going to write an equation for him. So let's write her equation. So her equation, where is she starting off? Her starting point is at 0. So she starts at 0. So that's your B, right? Let me write this in a different way. So this is her start, which tells me that B equals 0. What is the rate that they give me for her? She is walking at a rate of 6 feet per second. Now, is her distance increasing as she's walking? Is she going to be going farther and farther away from 0? Yes, so because she's increasing, she is a positive 6 is her rate. So her equation is just going to be y equals 6x. She starts at 0 and she's going positive at a rate of 6. Now his story is a little bit different. He is starting at 380. He's not starting at 0. So your B for the man is 380. And he's going at a rate of 2 feet per second. But as he's walking to her, is that 380 going to get smaller as he's walking towards her? Yes. So his distance is actually decreasing. So his rate is 2, but it's actually a negative 2. This is really crucial into setting up your problem. Understanding that one of their distance is increasing and the other one is decreasing in order to figure out where they meet. Okay, so his equation will be y equals negative 2x plus 380. That's the hard part. Now that we've gotten both the equations and an understanding of where the numbers are coming from, now we can solve it with substitution. So if I know that y equals negative 2x plus 380, I can replace it with the other y in the first equation, like I've been doing all lesson. So instead of y equals 6x, I'm going to have negative 2x plus 380 equals 6x. Okay? I'm going to add the 2x on both sides to get 380 equals 8x. Divide both sides by 8. And I get that x equals 47.5. So the question of when will they meet? They will meet after walking 47.5, what is this, seconds. Okay. Tricky setup for this problem, and if you have questions on how I set this up or where I got my numbers, please come talk to me in class. Please, 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 or talk to Ms. Vasquez or Ms. Samer. They'd be happy to help you out. Okay? Good luck on your fluency. Don't copy your answer keys, and for the third time, ask me for help. Good luck.